Hello and welcome to another walkthrough. Now this time it will be Edexcel A2 level further maths core pure paper 1 May 2025, which I have never seen before. So this is going to be a blind solve for the entire paper under the real exam conditions. So along the walkthrough I might be making mistakes, which I'll correct if I realize in the walkthrough, but if I don't, I'll annotate the video and I'll try to explain the worked solution and the thought process as simply as possible. At the end of the walkthrough, I'll mark the paper anyway. For those of you who make mistakes a lot of times, you might benefit from seeing me making a mistake and correct it later. So this walkthrough is not meant to just show you the destination of the solutions, but also show you the journey to the destination. If you feel like jumping to a particular question, you can use chapters in the description. Otherwise, stick around. You might be getting some tips along the way. If you are ready, I'll see you in there. Okay, so here's the paper. And I'm going to hit the timer now. Okay, let's go. That's question 1 there. I'm just going to do it here on the right side. Question 1, given the matrix M here, with some unknown A here there. Determine the values of M for which matrix M is singular. Okay, that's not too bad. Well, singular means the determinant of M is 0, right? So singular means doesn't have an inverse, right? So we're going to put the determinant of M being 0. Now, well, the way to find the determinant of a 3 by 3 matrix is to do the minors, yeah? Is to do the minors and then multiply with each element of a row or a column. So you got to pick a row or a column. Most people would go for the top row, but you can pick any row or any column, right? So for example, if you actually pick the second row here being A, 3, and 1. So the minors that you need to do will be A times minor multiplied with the element in the rows, right? So A times, and then the minor of the second row and first column here, yeah, would be 6, 0, A. And you have to apply the cofactor here because you have, so the cofactor would be plus minus plus, minus plus minus, plus minus plus. Yeah, so if you use the second column, it would be a minus plus minus. So minus A times the minor of the A and plus 3 times the minor of the 3 here, which is cancel, delete the second row, the second column, you get 3, 0, 2A, and so on, right? So it is usually wise to choose the row or column with some zeros. So here you can see you either pick the first row or the third column would be the wise way. So I'm just going to go with the first column, yeah? So that would be 3 with no minus there. And the minor of 3 here would be 3 times A. I'm just going to write this down first. Yeah, and then minus 6. And then the minor of 6 there would be A1 to A. Yeah, just delete the row and column at 6 there. Yeah, just double checking. And then the other one would be 0. That's why it's wise, because you don't need to care about the minor there, because it's going to disappear. All right. Let me double check again. Yeah, okay. So we're going to put this equal to 0. So doing the determinant of each minor there, it would be 3 times 3A minus 6 times A squared minus 2 equals 0. Right? And we're going to find the values of A there. So 9A, I got to be careful with the way I write A and 9 here, right? Because it's quite similar there. So 9, is that A and A? Hang on. It's 3 and 1, A and A, yeah. So let me write A like that, yeah. And then I have 3A. Oh, hang on. 3A minus A. Yeah, okay. This is 3A minus A. It's going to be 2A then. Okay, I got confused by my handwriting, and I have seen some students get that too, yeah, so you got to be careful there. Yeah, so that's 6A minus, is this the right kind of setup already? I have A squared minus 2, yeah, should be fine. So 6A squared plus 12. Yeah, okay, so this is, if I divide across by my 6, I get A squared minus A minus 1, right, equals 0. a squared minus a minus 1 equals 0. Okay, that's a bit weird now. I'm going to check my working here, because seems like I'm going to get a third value there. Okay, let me double check my work. So minus 3a minus, okay, that's 2a, and I got 6a, 3, 6, and 0. So this is going to be a squared minus 2 with a minus sign there. A squared minus 2, yep. Okay, what's gotta be, gotta be. Yeah, so yeah, I'm gonna go with that. All right, so a is just using the quadratic formula there. So minus 1 plus or minus square root b squared minus 4 times a times c, divide all by 1 times 2. Okay, so that would be 1. What's inside there? So we have plus 4, so this is root 5 divided by 2. So that's the values of a. Okay, yeah, that took a while. Probably needed some warm up, right? Given that matrix M is non-singular now, right? And that determinant M equals minus 108. Okay, now it's non-singular. So that means the determinant is not equal to 0. Or a is not equal to that, basically. Okay, and a is less than 0. All right, so because we were trying to find the determinant before and we already got this, right? This is the determinant in it, yeah? So we're gonna just equate 6a minus 6a squared plus 12, right? Because that's the determinant. Put that equal to minus 108, yeah? Now it's non-singular, so that is the determinant. And then again, I divide across by minus 6. What do I get here? So I get a squared there, right? And then minus a here. Well, if you move minus 108 to the left side first, you get 120. Divided by minus 6, you get minus 20. Yeah? Okay? So we can factorize this, of course, because we expect to get some meaningful a here. So I would say 5 and 4. 5 and minus 4. Okay? Actually, minus 5 and 4 there, but the answer is 5 and minus 4. You know what I mean, I hope. So because a is less than 0, we're going to reject that. Wait, hang on. A is less than 0, we're going to reject this. Sometimes you do autopilot, so you got to be careful not to just go for positive values always. So here, we need a to be less than 0, so a is minus 4. And now we're going to determine the inverse. Now we get the determinant, okay? So the step of finding the inverse is to first find the determinant. We have done that. Second is to find the minor, yeah, the matrix of minors, and then the cofactor, and then the transpose of the cofactor. So it's going to be 1 over d, and then this will give you the adjoint, right? So adjoint of M would be that. So it's basically 1 over determinant times the adjoint of matrix M. That would be M inverse. It's just some mnemonic that you can use DMCT. So let's do DMCT. We already did the D. So what's the M? Well, the M, which is the minor. Yeah, so the minor would be the minor matrix. Well, basically you just do like I did in the determination, and you just do it for all elements, right? So we basically gonna do like this matrix here, a large one. And then for example, for 3 here, it's gonna be deleting the row and the column at 3. So we get again 3, 1, A like this. Well, actually we already did the first row, right? So I'm just gonna copy the result there. So A1 to A, A1 to A, yeah, like that. Yeah. That's for the 6, right? Yeah. But now we don't multiply by the element there. We just get the minors, yeah. Yeah, A1 to A, and then, well, A is minus 4, right? So I'm just gonna put minus 4 in there. This is minus 4 and minus 4. You gotta be careful there. And this is minus 4 and 1, right? Yeah, minus 4, 1, 2, minus 4. And then for the 0, right? So it would be, cancel the row and column for 0. You're going to have A3 to A. So it's minus 4, 3 to minus 4, right? And then you do that for all other ones. Yeah, so it's a little tedious here. So here 6, 0, and then minus 4, minus 4, right? Just have to be very careful. It's a tedious and requires a lot of care here. I'm just, because I need to talk as well, so I have to pay extra attention here. And then the middle one, so it would be 3, 0, 2, minus 4. This one, it would be 3, 6, 2, minus 4. Okay. Okay, I'm warmed up now. So this one, 6, 0, 3, 1. This one, what's this one? Okay, hang on. Yeah, it's 3, 0, minus 4, 1. This one, 3, 6, minus 4, 3. Okay? Now, yeah, you got to put the cofactor in. So this is the minor. And if you want to apply the cofactor already, you just put minus, 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 minus. Yeah? Okay. So minor with cofactor, I'm just going to do that, 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 and that. Yeah? Okay. And then you're going to get the matrix of the minor. And then you're just going to transpose the thing. Yeah. Let me just shrink this down and put this up here. Okay. So I'm just going to do C here already because it's the matrix of cofactor when you do minors already. So the first element would be 3 times minus 4 is minus 12. Minus 12 minus minus 4, so that's minus 8. Yeah, the first one. Okay, minus 12 minus minus 4. Minus 12 plus 4 minus 8. And then this one is 16 minus 2. So that's 14. And then we have to put minus, so minus 14. This is, wait, hang on. 16, yeah, I'm just checking. 16 minus 6, so that's 10. There's just 10, no change in sign. And this is what? Minus 24 minus 0, that's easy. So put a minus sign, becomes 24. This is minus 12 minus 0, so that's minus 12. This is minus 12 minus 12. That's minus 24, so become 24. This is 6 minus 0, so that's 6, no change in sign. This is 3 minus 0, so that's minus 3 because there is a change in sign. This is 9 minus minus 24, so that's 33 in it. 24 plus 9, 33, no change in sign. That one is weird. Let me double check. Yeah, that should be fine because A is minus 4. Yeah. Okay, so that's the cofactor. So cofactor transpose would be, well, you just write the rows as the column. So minus 8, minus 14, and 10 there. Is it 10? Yep. And then 24 minus 12, 24. And then 6 minus 3, 33. Yeah, like that. That is the adjoint now. This is the adjoint of matrix M. So adjoint of M. Yeah. That means the matrix M inverse, right? The M inverse would be 1 over determinant, which is 108 minus 108. And then we're going to write the whole thing there. So minus 8, 24, 6, minus 14, minus 12, minus 3, 10, 24, 33. See if I can divide everything by some number. Probably not, because I thought 3 would be the factor of everything, but no, you have still 14 and everything. So wait, hang on. Yeah, you still have 14 there, so not really. I'm just gonna leave it at that. Yeah. Okay. Number 2. Determine the exact values of x for which sinh 2x is equals to 3 sinh x. Okay. Well, interesting. So we can use the additional formula, right? Let me just check the formula sheet. Let me just go to the formula sheet there. Okay, so we have, double angle, just like in normal trigonometric function, like the double angle here. Yeah, so we can do that. Okay, so I'm just gonna go back to the paper. that means we can do, on the left side we have 2 sinh x cos x equals 3 sinh x. I guess that's the way they pronounce it, if I'm not mistaken. Or you can say sin h, yeah. And then I would pull everything on the same side, right? Because you can't just cancel sinh x there, because you would omit some answer. I mean, if you are aware that it can be 0, then it's fine, right? But here we factorize sinh x, and then we get 2 cos x minus 3 here. Yeah? And now you would see that you have sinh x equals 0, or cos x equals 3 over 2, right? Okay? So to find the answer, we do arc sinh and arc cos, yeah? And there is a formula for that in the formula sheet. So here x is arc sinh x, arc sinh 0, and here x is arc cos 3 over 2. And I'm just going to go to the formula sheet again. Here we go. So as you can see, we have formula here. Now the condition is that for cos here, x has got to be greater than 1, right? So when you put in the argument there, yeah. So we need to do, yeah, for cos is greater than 1, 3 over 2 is greater than 1. For sinh, there's no condition, so we're fine. So for sinh here, it's just going to be ln 0 plus square root of 0 plus 1, which is ln 1, which is 0. Yeah, that's trivial, because sinh of 0 gives you 0. Obvious. Just like sin x equals 0, you get x equals 0. For this one, arc cos 3 over 2, so we're going to use the formula here. It's going to be ln, well, similar to the sinh formula there. It's just ln 3 over 2 plus square root of 3 over 2 squared plus 1, yeah? And then what do you have there? Is ln of 3 over 2. Well, in the square root, right, we have 9 over 4 plus 1. Well, that would be 13 over 4, right? Yep. So that's just plus root 13 over 2. Because if you have root 4 down there, it's just 2. And then let me put that into 3 plus root 13 divided by 2 there. That's just the exact value. Okay, so we're done. So it's just x equals 0 or ln 3 plus root 13 over 2. That would be the answer there. Okay, let's go to the paper. Number 3. Okay. Part A, the complex number z equals blah, 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 and then we have z divided by its conjugate is purely imaginary. So that means the real part is 0. Show that a squared equals b squared. All right. So when you have a plus bi, which is the z, divided by its conjugate, which is a minus bi, yeah? It's given that this is purely imaginary, so we need to do some rationalize here, just similar to rationalize, yeah? So we are multiplying by a plus bi there on top and bottom. Yeah. So you would get on the top, it would be a squared. Yeah. A multiply a. And then you have 2 of the abi, right? 2 of the abi. And then the last times the last here, you get b squared times I squared. So that's minus b squared, right? Divided by, well, this one would be a squared plus b squared. If you have done a lot of practice, you will see that it's always a, a squared plus b squared there. And, well, because there's no real part here, well, let's sort of split that into real part and imaginary part. So you get a squared minus b squared here divided by a squared plus b squared, right? That's the real part. And then the imaginary part is just 2ab divided by a squared plus b squared and I right here. Yeah, just split into the I here and the real part here divided by a squared plus b squared. So we are given that the real part is 0. So we say a squared minus b squared divided by a squared plus b squared is equal to 0. That means we have to cancel this thing out. And then we can say a squared minus b squared equals 0. Therefore, a squared equals b squared as required. Okay, that's just part A done. Given also that z times z conjugate is 50. Okay, So part B, it's just a plus bi times a minus bi, right? That would be again a squared plus b squared. Again, I'm just doing it again. And we're given that this is 50, right? Yeah. Determine the possible complex numbers z. Okay. So right, okay. Okay, so a squared minus b squared is 0 and a squared plus b squared is 50. Yeah. So if we add them up, what do we get? We get 2a squared equals 50, right? Yeah. A squared is 25, so a is plus or minus 5. If a is plus or minus 5, that means b is also plus or minus 5, right? Possible complex numbers z. Okay, so is it just going to be... Okay, so if a is 5, b is 5 or minus 5. So I guess we have 4 cases. Hang on, we got to be careful there. I'm checking all the conditions because we might have many cases here. At most 4 cases, I guess. It's like if a is 5, b can be 5 or minus 5. And if a is minus 5, b can also be 5 or minus 5. So there are 4 cases, right? Yeah. And if we consider all of the conditions here, well, they all work, right? I mean, if we consider back here, if we check the squares and the equations, a can either be 5 or minus 5 regardless of b. Yeah, so I need to say that z can be plus or minus 5 plus or minus 5i. That's just a way to put it in short. Yeah, possible complex numbers z. That's it. So there are 4 cases here, basically. Yeah. Wait, just to be safe, yeah, I'm just gonna write like, just gonna split them up, yeah, or 5 plus 5i, comma, 5 minus 5i, comma, minus 5 plus 5i, comma, minus 5 minus 5i, yeah, they're all different. Okay, yeah, I'm gonna go with that. I think so. That should be fine. Yep, I think that's okay. All right. Yeah. Hang on. Yeah. Number 4. Determine the general solution of differential equation that. All right, giving your answer in the form y equals fx. Right. So this is general solution. We needed to find the particular integral as well. Let's do that first, right? So the particular integral, when you have 2e to the 3x, like that. Well, you know what? Let's actually do the complementary first, because sometimes the particular integral can be the same as the particular integral. Okay, so let's do CF first. I'm just going to do m squared minus 4m plus 4. That's the step there. You just take the coefficients and solve this quadratic first. So what's that? It's just m minus 2 squared, right? So this is a repeated root. Yeah. So m is 2 repeated root. Then we do y. Is this y? Yeah, y equals. Then it's a plus bx. And then e to the 2x, like that. Yeah. That's the repeated root. So the e to the 3x for the particular integral on the right, like the non-homogeneous part on the right part, is not the same as e to 2x here, so we are good. Yeah. And then particular integral, we're gonna try y equals, well, the form is you need to do lambda e to the 3x there. All right, that's just the way to go. So you need to do the same power but some unknown constant. Okay, so we need to differentiate this and we put it back to the original differential equation. So this is 3 lambda e to the 3x. If you do second derivative, then we would get 9 lambda e to the 3x. So that's pretty simple. So putting everything back in the original equation, so 9 lambda e to the 3x minus 4 dy by dx. Yeah, I'm just going to put everything first. plus 4y, which is still lambda e to the 3x. Put that equal to 2e to the 3x. So this is just to find the actual value of lambda, right? So what do we have here? We have 9 lambda minus 12 lambda plus 4 lambda, all times by e to the 3x equals, what was that again? 2e to the 3x. And as you can see, e to the 3x can cancel, so we have in the brackets there just lambda equals 2. Well, okay. Yeah, that can happen. Let me see. Minus 3, yep, I think I'm happy with that. So just lambda equals 2 there. That means the y of particular integral would be equal to 2e to the 3x. So the general solution, y general solution, is when you add those two together. Yeah. So it would be a plus bx e to the 2x, right? That's the complementary function. And then plus 2e to the 3x, yeah? That would be it, the general solution. And of course, next part B, we now get conditions, yeah? And you need to solve for the particular solution. Well, that's not too bad, yeah? So we're gonna find the dy by dx first here. After we get the general solution, we need to find dy by dx because they give the condition for the derivative function here. Yeah, so that's why you need to differentiate to put the condition in. So differentiating that, well, let's do product rule there. So u there, dv, so dv is 2e to the 2x, right? Plus v, which is the e to the 2x, du. So you differentiate inside the brackets, you just get b, right? So it's just b e to the 2x there. That's just the first term. Differentiating this term, you get 6e to the 3x, yeah? That's dy by dx from the general solution. So let's put x equals 0. You're going to get two conditions for the y and for the dy by dx. So for the y, you put 5 equals, well, we're just going to do this whole thing, yeah? Substitute x equals 0 in. So we get, this will be 0, so that's just a e to the 0 is 1, right? Yeah? Plus 2e to the 0 is just 2. So simply a is just 3. And then for the second condition, dy by dx of 12, we're just going to use this equation. We just differentiate it. So again, x equals 0. That's going to put just 2a, and e to the 0 is 1, plus e to the 0 is 1, so that would be b. E to the 0 is 1, so that would be 6. But a is already 3, so we put that. So 2a is 6. 6 subtract, well, b is 0 actually, yeah? Because if you do the math there, 2a is 6. 6 plus 6 is 12, so b becomes 0. So the particular solution would be then, because b is 0, so we get a e to the, wait, a is already found too. So 3 e to the 2x plus 2 e to the 3x. Quite simple there. Okay, so that's the particular solution. Okay, done. Now question 5. Use method of differences to prove that n for n greater than 2. Okay, blah, blah, blah. Well, yeah, to compute the method, to use the method of differences, you need to do two fractions first in the series. This is not yet the form. So you need to do some partial fraction here because the fact that 4 divided by r squared minus 1 can be split like, the denominator can be split into this, right? Yeah, it's the difference of squares. And you can put it to a over r plus 1, plus b over r minus 1 like that. And then once you get the two partial fractions, you can put it back, and then you can do some some substitution work to see the pattern, yeah, and get the series. So it's probably going to be 2 and, hang on, what's going to be? Yeah, you can multiply out, so I'm going to get 4 equals, so it would be a r minus 1 plus b r plus 1, right? So we need a and b to be, a plus b should be 0, right? Because if you look at the term r and r, Or you can do substitution with the critical value. Okay, that also works, but I just try a different thing. Okay, so I equals 1, we get 4 equals 2b, so b equals 2. If I equals minus 1, because these are critical values, yeah, so 4 equals minus 2a, so a is minus 2, just like that. Yeah. I'm just checking. Yeah, so that's fine. So we have, yeah, so we have that thing now turn to, I gotta be careful with the a and the b here. So the a is minus, so I'm gonna do b first. So b is 2 over r minus 1 plus, this is minus actually, 2 over r plus 1. I just put the a in the second term, yeah, because there's a minus there. Okay, and now this would be what? Now we get this series instead, right? This formula. So if we substitute r equals 1, right, we're gonna get 2, sorry, not 1, it starts from 2. So we need to start from 2. So 2, we get 2 over what? 1 minus 2 over 3, right? Yeah. If r equals 3, and then you keep going, you get 2 over 2 minus 2 over 4, right? Don't simplify anything because you won't see the pattern if you do, right? Just keep going there. Just maybe a couple of terms there. And r equals 4, you get r 2 over 3 minus 2 over 5. Now you start to see some cancellation, like this one and this one here. Yeah? Probably it. I probably need another one there. R equals 5. You get 2 over 4 minus 2 over 6, right? So this one cancel that one. Okay, let me have a look here. Okay, I need to keep going a little more here. So r equals 6, so we have 2 over 5 there, minus 2 over 7. Wait, hang on. Something's not right, maybe. Why did I cancel 2 over 5 there already? And it shouldn't be cancelled. It should be cancelled here, right? What did I cancel it with? Oh, this is a minus 2 over 4, sorry. Yeah, should be cancelled with that, and 2 over 5 cancelled here. Now, if you keep going, you will see that, well, these two won't be cancelled, will they? Yeah? And, I mean, if you try to maybe, let's assume that, let's say n stops at r equals 6, right? Let's say n is just 6, so this will be the last term. And as you can see, the last term you have left with the first two terms, of course. Regardless of the value of n, you always have the first two terms. Maybe if n is maybe greater than 3, you're going to have the first two terms for the least. And you have, you know, the last term from the second last r and the last term from the last r. By that I mean if you keep expanding to 2 more terms, like I mean if you keep expanding, and let's say I keep expanding to the last term being r equals n and the second last term being r equals n minus 1, let's say. So what would that be? This will be 2 divided by n minus 1, replace the r. So n minus 1 minus 1, you get n minus 2, minus 2 over n minus 1 plus 1, this will be 2 over n. And then for r equals n, you would have 2 over r minus 1 minus 2 over n plus 1. I'm saying that because we know from the trend that when we assume that r equals 6 is the n, or n equals 6, we would get this term and this term. It tells you that these two will be left. Yeah? So actually, the term that is also, the terms that are also left uncancelled would be these two. Not the last two terms, because the last two terms would have been these, but it's these two. Okay? So, I mean, imagine if you keep going R7, R8, yeah, these will be cancelled anyway. This will be cancelled, but these two terms are left, right? I hope you're okay with that. Make sure you understand this first, because it's gonna usually be like this, yeah? That means you would have this equal to 2 plus 1. This is 2, this is 1, right? Easy, yeah? All right. And then plus, minus 2 over n from here. and minus 2 over n plus 1. And if you simplify that, you will get it to where they want there. Okay, hopefully that works, right? So, well, look at the denominators here. At least we get the same common denominator is n times n plus 1. So you're going to have to multiply the 3 here, the constant term, with n times n plus 1. And minus 2, this will be multiplied by n plus 1 because it already has the n down there, so you just multiply by n plus 1. And this one will multiply by n. And all divided by, the same denominator there. It's just a quick way to simplify these or these fractions. Now you just do the math there. So this is, do we need to? Yeah, we just expand, I guess. So 3n squared plus 3n minus 2n minus 2 minus 2n, all divided by n times n plus 1. And if you simplify that, well, we get, that's 3n squared minus n minus 2, right? Hopefully we can factorize that. We should be able to. So 3n and n maybe. I'm going to go with 2 and 1, and that's minus here plus here, right? Yep, that works, right? Doesn't it? N plus 1. Yeah? So that's probably it for this one. Yeah, I have proved that. Okay, so this is the substitution work I was talking about. Okay, so that's done. That's nicely done. Yeah, we got n minus 1 there, so that's a kind of like the indicator that we got it right. Number 6. All right, so some more complex number there. Okay. Given the fz is that, okay, the roots of the equation fz equals 0 are z1, 2, 3. When plotted on Arctan diagram, the points representing these roots form the vertices of a triangle. Well, yeah, okay. Given that z1 is that, they give you one complex root. That means, well, if z1 is that, then z2 is just the conjugate of that, right? Yeah? Okay, now, okay, yeah, let's find the, should we go with the quadratic form already here? Okay, let's actually plot this because the other root should be a real number root because you can't have one single complex root, right? That doesn't have any conjugate. So if we plot the Arctan diagram as they say that, we already have 2 here, let's say, and 4 and minus 4 here. And then we have 1 point here, 1 point here. So these are the 2 vertices that we know for the triangle. Now, how to make this 12, right? So, well, if we make that the base, you see, if we make this the base of the triangle, right? I'm just going to make this the base. And, well, let's say one case is like that, a triangle. I mean, it can move along this vertical, but we know for sure that there is a height here that can be determined because the area of the triangle is 1/2 base height. We know the area is 12. We already know the base because we made the base to be this line, which is 4 minus minus 4, so that should be 8 for the base, and height is something. So if you solve that equation, you cancel, you get 3 for the height. That means this distance is 3. It could be the other way, of course, like that, with the same height, right? But it's going to be along this vertical. Now that's what we know, right? 2 possible functions. All right. So, but okay, if the one on the left is that, then the one on the right should be mirror image like this. Yeah, I think it's like that. 2 cases there. Now we need to use the okay, I see. Okay, no. We know the x value of these two because the fact that this is 3 units away. So that should be what? 3 units away, so that would be -1, and that would be 5, right? Because this thing is 2. Yes, 2 plus or minus 4. Okay, so we know that Z3 has the real part to be -1 or 5. Wait, hang on. Because we also know that the other root must be a real number, so it should be on the x-axis. I forgot about that. Okay, so it should, either be that triangle or that triangle. So some logic there, yeah. So it's -1 or 5. That's it. So for the fz there, then we have to multiply the two quadratics, one quadratic from the two complex roots and another linear factor from the real root here. Yeah. So the way you do the quadratic, right, to get the, because look, the fact that you got the complex root here is from, you know, z squared, like az squared plus bz plus z equals 0, right? And then remember, when you do quadratic, you get minus b plus or minus blah, 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 okay? But, I mean, you can also look at it like this, yeah? Because if I divide across, this is cz, okay? Wait, hang on, just c, sorry, no z there. Yeah, if you divide across by this, yeah? And then with the knowledge of roots of quadratics, you also know that the two roots, if you sum them up, you get the middle term, like the minus b over a. If you multiply them out, you get z1, z2, which is c over a. Let's do that. So z1, z2 there is equal to, wait, let me add them up first. So if I add z1 and z2, I get 4. So we know that this would be minus b over a. So b over a would be minus 4, right? Yeah? b over a would be minus 4. It's the middle term there, when the first one is already 1. And if you do z1, z2, what do you get? Well, just multiply them out, right? So you would, these are conjugates, so it's just 2 squared plus 4 squared. Yeah, because they always add up there, the squares. So 2 squared is 4, 4 squared is 16, so that's 20. Yeah? Okay, so that means this will be equal to c over a. So we have z squared minus 4 plus 4z, sorry, plus 20 equals 0. That's the quadratic roots, right? So that means we can put it here. Yeah, we can put it z squared minus 4z plus 20. Okay? Because we know that it's given that the first term doesn't have any constant there, the first term here. So we are good. This is 1, right? So we are okay. And then the other one is just z plus 1 because from the root there. Yeah. And the other one would just be z squared minus 4z plus 20. That doesn't change, but the real part can be this. Yeah. And then I guess you just multiply them out. So I'm going to squeeze a little bit, or maybe not. I'm just going to, you know, move them here. Let me just cut them, or actually copy them, cut them, and put them here, yeah? Okay, so I'm just going to expand basically. So this is z cubed. And then for the z squared term, so you have 1 minus 4, so that's minus 3z squared. For the z term, you would have minus 4 and plus 20, so that's plus 16. And the number term would be 20. For this one, it would be z cubed. Is it the same for? No, probably not the same. So we have the square term, we have z minus 5 and minus 4, so that would be minus 9 z squared. And then for the z term, we have 20 here plus 20. So 20 plus 20, isn't it? Yeah. 20 plus 20 is 40 z. And then this times this, we get minus 100. That would be it. Right? So these are the two functions. Okay? That's it. Done. Number 6. Okay. Wait, I need to check how long I have here again, because I normally, okay, an hour and a half, good. All right, so where are we now? Number 7. Number 7, we have something. This is, yeah, okay, let's express that in partial fraction first, part A. Well, this is partial fraction where you have some weird denominator. Shall I put that? So let's put it to 2x. Well, let's do, yeah, you know, let's just do, so the left hand side, which is the given form, is equal to a over x plus 2, yeah, plus, well, because the other factor in the brackets there is a second order. That means on the denominator, you need to put the linear form, not a b, it's bx plus c. It's a linear form because the bottom here is a quadratic factor because it's x squared. And that's it. So if you multiply out by x plus 2 times x squared plus 3, you're going to get the left-hand side being this. Yep. Equals, so a would be multiplied by the quadratic factor, and bx plus c would be multiplied by the linear factor there, the one and only. And then you just do the partial fraction step. So I'm just going to substitute by x equals minus 2, right? So here I would have minus 8, so that's minus 16 for the first term. That's 40. That's minus 18 plus 22, yeah? So what's that one? Well, this one will go to 0, so we are only having this one. So minus 2 squared is 4, so that's 7a. That would give me a. So that would be 4, 44, hang on, 24, 6, 28, so a is 4. Let me do that again. 24, 6, 28, yeah, a is 4. And then if I substitute a as 0, just pick the easy one because you can't really make a critical value here. X squared plus 3 has no roots, has no critical value, so you just have to make some easy number. Well, that's easy because these will disappear, right, if I sub 0 in, so I get 22 there. And then that would be 3a plus c times 2. That allows me to find c. Yeah, let me just double check that. Okay, so c would be what? 22 minus 3a, which is 3 times 4, divided by 2. So what's that? 22 minus 12 is 10. 10 over 2 is 5. So that's c. And then we're just going to go for another one. Let's make it easy. 1. Okay, so the left part would be 2 plus 10 plus 9 plus 22 equals, we'll substitute 4 in and 1 in x, a in 4, or 4 in a, sorry. You get 4 times 4, which is 16 there. Yeah, I hope you follow. Plus, well, b we don't know. We are finding it here, so we're just going to do bx, which is x is 1, so that's b, plus c is 5, and then x is 1, so that's going to be 3, right? Yeah. Just carefully work through it, yeah? Okay, so the left part is 12, 21, so that's 43 in it. Yeah, equals, what is this? 16 plus 3b plus 15. So the right side, we have a constant of 31. If we subtract 31 to 40 from 43, we get 12. Yeah, so this is 12 equals 3b. So b equals 4, right? Yeah, I think I'm happy with that. And now we found it. So the left-hand side is just going to be equal to, what's that? A was 4 over x plus 2 plus b is 4x, and then c is 5 divided by x squared plus 3. So that's the partial fractions form. Okay, that's A done. Part B. Hence show that if we integrate that, we're going to get that. All right, so that's fine. Well, integrating this is fine, right? You're going to get L in there. Well, how about integrating this, yeah? Well, we need split. So do that. Because, look, you can't really use any reverse chain rule trick there for that one. Because if you, I mean, for those of you who've done pure math, right? Of course, you should have. That means like if you differentiate the bottom, you don't get kind of like a factor of the top. Then reverse chain rule doesn't work here. That means we should split. And the way we split, we need to refer to the integral formula. So let me show you. Like, hang on, let me go to the, yep, one of these. So look, we have x squared plus a squared as the denominator here. So if we look to integrate something like this, we get 1 over a arctan x over a. So that's good. So if we can split the 4x and the 5, right? And yeah, so I mean, if I can split plus 4x over x squared plus 3 and plus 5 over x squared plus 3 like this, you can see that the 5 over x squared plus 3 is applicable for this integral formula now. Yeah, that's just root 3 squared basically for the a. And then for the other one, we can use the reverse chain rule. So for this one, we use reverse chain rule. All right, so that's going to work. Okay, so I'm just going to keep this formula page on first. So that's going to be 4 ln of modulus x plus 2. That's easy. And this one, well, I'm going to do this one first, right? So that's just 5 of, well, a would be, here a would be root 3, right? Yeah, according to the formula here, arctan. This one, yeah? Is there any other one that's similar to this? No. So we're going to go for this one. Okay. So that's going to be 1 over root 3, right? Arctan x over root 3. Yeah, like that. Okay. And this one, right, is a reverse chain rule. So I'm going to go back to the paper now. So how do we do reverse chain rule? Well, we try differentiate the bottom. Yeah, I mean, you should go check the easy way to do reverse chain rule. I mean, if you have forgotten how to do it quickly, because, I mean, if you don't do reverse chain rule here, you're going to need to do substitution, which takes a little time. But if you do reverse chain rule, just try differentiate this, you get 2x, right? And because you don't exactly get the top bit, yeah, just try check the video there. I explained it very carefully. Because when you differentiate the bottom, you don't get exactly the top. You need a correction factor of multiplying 2 here to get exactly 4x. And that will be the thing you multiply with the reverse chain rule form. Because when you kind of like differentiate the bottom and get kind of like the top, you can do ln the bottom, which is that. But multiplied with the correction factor there, what I call. Yeah, okay. So that would be plus 2 ln x squared plus 3. And that's all the integral there. We're going to keep this working here. Okay. All right. That's it. So we're going to put the limits on. That's from 0 to 1. So we're just going to write like that. Now, let's simplify this a little more. Because we can, right? Like, if you consider this, yeah, you can put like, you know, should I? I mean, yeah, why not? Or, no, you know, I'm not going to simplify it. So just put the limits. So the upper limit putting in, we get 4 ln 3 for that, right? Plus 2 ln 4. Yeah, because 1 plus 3 is 4. And then plus, what's this? Well, arctan 1 over root 3. Well, using a calculator, because I happen to remember that tan of pi over 6 is 1 over root 3. So this is pi over 6. So that's going to be plus 5 over root 3 pi over 6. Yeah, that's it. Or we can simplify this a little more, just writing 5 pi over 6 root 3 like that. Yeah. All right. So that's it for the first term. Now, for the upper limit, so the lower limit substituted in, we get minus 4 ln 2 there for the first one, plus 2 ln, wait, hang on, it should be minus because now I expand the minus sign, 2 ln 3, right? Okay. And then, yeah, the last term, well, if you plug 0 into the x, you get arctan 0. Arctan 0 is 0, right? So everything vanishes there. So this is it. Well, let's combine all the ln terms. So what do we have? We have this and this, yeah, the ln 3. So I have, that will be 4 minus 2. So that would be 2 ln 3. And this, right? So 2 ln 4 is basically 2 times 2 ln 2. So that's 4 ln 2, right? and that would cancel with this. Yeah, so we just have the 2 ln 3 plus 5 pi over 6 root 3, is it? Uh-oh. Hang on, that's really not what we expect. Okay, I'm doomed. Hang on, am I doomed? Did I forget anything? Right, hang on. Okay. I'm gonna check the integration again. And then I'm gonna check the substitution. If nothing is wrong, then it's probably the partial fraction. All right, let's check this. Oh, wait. Oh no, that's right. So that and 2x times 2, yeah, this should be a correct integral. Wait, hang on. 4x and 5, yeah, I split them. Yeah, so you will see this is a valuable time because I'm finding my own mistake. Let's hunt down the mistake, yeah, because definitely we don't get what they want there. Okay. So did I use the Arctan formula correctly there? Yeah, I think that's fine. That's all fine. Okay, let's check the substitution again. So if I plug 1 in, I get this one is right, this one is right. 1 over root 3 is pi over 6, so this one is right. And then the 0 there, so the 0 is 4 ln 2 there, a minus. 0 goes here, a minus 2 ln 3, yeah. And then a 0 here, I get 0 there, which is 0 vanishes. And then I simplify this and this. Okay. Right, I think it's from the partial fraction part. Let me just double check the partial fraction. So if I kind of like simplify this, I mean, if I simplify this to a single fraction, do I get that? Well, if I do, then it should be right. So let's just check backwards here. So if I cross multiply, I get 4x squared plus 12, right, for the left part. And this will just be x plus 2 multiplied with the 4x plus 5. So that would be 4x squared. And then I got 8x and 5x. So that would be 9x plus 10. Do I get to the top there? Wait, what? I don't. There's no x cubed term there. There's something wrong now. Pretty much. Oh no. I forgot one key step. This is a cube. This is order 3, and this, if you multiply this out, it's the same order. I should have done the long division first, so this whole thing collapses. This whole thing fails. That's a big mistake there. Right. Okay. Yeah, long division. Wait, hang on. I can use the result here because when I multiply the... No. Yeah, let's just... Okay. So when I multiply out this, I'm gonna have 2x cubed plus 10x squared plus 9x plus 22. I need to hurry up. My time is running out. So multiplying that out, I get x cubed plus 2x squared plus 6. No, plus 3x first and then plus 6. Yeah, let me check that. Don't want to make any mistake again along the way here. Okay, let's do a long division here. I mean, usually it's just a quick long division because you divide by the first thing here and then that's it. Actually, it's just 2 and then the rest, yeah. So you have 2x cubed here plus 4x squared plus 6x plus 12. And then you subtract once, you get the remainder and you're done here. So not that much time taken here. But just have to be careful again. You can make a mistake anytime if you're not careful. So that left-hand side actually becomes 2 plus, yeah, and the same thing, yeah, basically like that. Where is it? Hang on. Yeah, it would be the no. It would be the remainder first here, and then the divider, which is those two factors again. Okay, now the divider is 1 degree higher than the numerator, so we're good. And we're gonna put this, yeah, with the two brackets, right, equals to a over x plus 2 plus b over that again, wait, hang on, plus bx plus c over this again. A little tedious here, but we need to do it. So again, x squared plus 3x plus 10 equals, I'm just going to be quick here, guys, yeah, because I already spent quite much time making that mistake that I not divide the whole thing first. Okay, so repeat the same step. If I put x equals minus 2, so that would be, let's check if I have that. Okay, minus 2, so that's 24 minus 6 plus 10 equals, so minus 2 squared is 4, so that's 7a, and that disappears, so that a becomes 18, so a is still 4. Okay, okay. All right, is it right? Yeah, it should be. So if put x equals 0, so that would be 10 equals 3 times a plus c times 2. So c would be 12 subtract 10, I get minus 2, so c is minus 1, huh? Some difference here. And then if we put x equals 1, we would get 6 plus 3 plus 10, that's 19 equals, again, 4 times a here plus b plus 4, yeah, and then that would be 3, right? So what would be b here? We get 16 there, subtracting 19, we get 3, divide 3, we get 1, b would be 2, okay? So there we have the partial fractions, left hand side equal 2, yeah, because we got 2 from here, and then plus a is 4 over x plus 2, plus bx plus c, c is minus 1, divided by the quadratic factor. Okay, so this should be good. And then we need to integrate this whole thing, so I'm just going to do this again. So it's basically integrating 2 plus 4 over x plus 2. Now we split this into, this is easier reverse chain rule. And then minus 1 over x squared plus 3. Yeah, everything is simpler now. Yeah, okay. So we're going to get, let's delete that out. We're going to use the same concept here. Yeah, everything is the same concept. So it's just 2x plus 4 ln x plus 2. So if you differentiate the bottom, you get exactly the top. So you can already write ln x squared plus 3 without any correction factor needed. Yeah, and then here you have minus, well, the same formula there. A being root 3 again. So we're going to have 1 over root 3 arctan 1 over root 3, right? No, x over root 3, sorry. Yeah, so 0 to 1. Okay, we should be good. Now let's put the bounds in quickly, guys. So put 1 in, we get 2 plus 4 ln 3 plus ln 4, which is 2 ln 2, right? Just make it simpler already there. Yep. And then again, arctan 1 over root 3 is pi over 6, so that's pi over 6 root 3. Yeah, we have pi over 6 root 3 there. All right. And then putting 0 in, the first term disappears. The second term gives me minus, right, because we have to do lower limit here, so minus 4 ln 2. The second term gives me minus ln 3, and the last term, the arctan, disappears. And then there we have it. So this is, what can cancel here now? It's 2. Let's do the ln, okay. So ln 3 would be 3 ln 3, that should work. The ln 2 would be minus 2 ln 2 and minus pi over 6 root 3. I think it works. So here would be ln 27 minus ln 4 plus pi over 6 root 3. Yeah. So if we merge the log there, we have ln 27 over 4 using the log property and minus pi over 6 root 3. Finally, this can happen in the exam, guys. So you need to be quite alert for any mistake that can happen along the way, which I made. Yeah. Number 8. That was a bit tiring. A rambler starts a walk at the bottom of the hill at 10 a.m. The rambler walks on the way to the top of the hill. Is this the last question? Let me check. It's not. We got 10 questions. All right. I feel a little troubled here. Okay. A, determine the value of A, 3 significant figures. All right. So this is first order differential equation. Okay. So I'm going to go with solving here. Determine the value of A. Just 1 mark. Okay, given that after 1 hour, so that's t equals 1, right? So t equals 1, just going to do t is 1, so that's in radian, right? Okay. Rambler has a vertical displacement, which is x, and dx by dt. Okay, so it's just sine of 1. Dx by dt is 273.2 minus x is 1 cos 1 equals a sine 2 sine 1. That's a weird trick equation. Okay, so we're just going to solve for a here using a calculator, of course. So that's just fraction. I'm just going to do radian first. Yeah. So sine 1, you got to put 1, is not 1, yeah. Times 273.2 minus 1 times cos 1, so I just put cos 1 in here, divided by, well, if you solve for a, you divide by sine 2 times sine 1, right? So a equals 299, 3 significant figures, so 300. I'm just going to do that first. Yeah. Okay. And then what? Part B. Hence, determine the particular solution to differential equation giving your answer in the form of x. All right, so we're going to have to arrange so that this is a first order differential equation first. If we divide everything by sine t, I get dx by dt. Yeah, you got to make dx by dt alone first on the left side. And this would be x times cot t, right? Because you have cos over sine, so that's cot t. Double t here, so it can be confusing. And the right hand side, the sine t cancel, you just have a, well, I'm just going to keep a first, and sine 2t, because the sine t cancels. Now, we need to find the integrating factor, yeah, the if, which is to be e, we are, hang on, what's that? Wait. Okay, it's this thing, yeah? It's this thing, okay. It's the e to the power of integral of this guy, right? Cot t dt, right? Cot t times dt here. Wait, cot t and dt, right? Like that, okay. Oh, it's got to be minus, right? So minus here. Because this is the form y times some function of x. All right, yeah. So the integral of cot t, let me just check the formula here. Integral of cot t. Do we have it? Integral cot t. I just forgot the formula. So let's look at the pure math formula there. Integral cot t, integral cot t. We don't have this one. Hang on. Where's? I can't find. Okay, found it now. So it's ln. It's just ln sine t, basically. So this is e to the minus ln sine t. Yeah. Integrate cot x, you get ln sine x, absolute sine x. Yeah, so that should be fine. Yeah, just put a minus there. Okay. So that means this is basically e to the ln of 1 over sine. If you put a minus here to the top, you get 1 over sine t, right? Which is 1 over sine is cosec t. So this is basically cosec t, right? And you're going to multiply that, so we have x times cosec t equals a sine 2t times cosec t. Basically the step here. And you can say that this is d by dt, right? Equals that. And now you need to just integrate both sides. So you have x cosec t equals, integrating both sides, we have integral. Let me put a outside that. So sine 2t, cosec is 1 over sine t here, dt. Okay? So this is a, well, sine 2t is 2 sine t cos t. So I'm just going to put 2 outside here. And then sine t cos t, well, sine t cancel with the sine t, I get cos t here alone. So that's going to be 2a minus, integrate cos, you get a sine. So that's no minus that. And then a plus c. And then I have x cosec t here. All right. That's the general solution. Now we need to find x in terms of t. So we have all the conditions there. Yeah, we need to plug in the displacement, right? Hang on. Wait. Oh no. I got it a wrong a. I just double check. This should be x, which was given to be. Oh no. The Rambler has displacement. Yeah, this is 213. Good that I saw this. Okay, let's calculate that again. So this has got to change too. So that part there. Multiply 213, right? Yeah, okay. I think this should be better at least. Yeah. Okay. Yeah. So it's 150 basically. But that wouldn't affect the second part here because I just kept it as a. I didn't plug in. Yeah, we need to find c, right? So again, we plug in everything. So if t equals 1, yeah, x would be 1, 2, 3 cosec 1 equals 2 times 150. I'm going to make 150 sine 1 plus c. So c equals, yeah, just 213 times cosec 1. So 213 cosec is 1 over sine, right? So it's just divided by sine 1 there, okay? And then that's going to have to minus 300, which is 2 times 150 times sine 1 as well. So that's not what? Really? Okay, that's a bit weird, huh? 0.68686. Let's make that 3 significant figures as well. So 687. Let me double check everything. So integrating factor was cot t minus cot t. I grade that, I get minus, yeah, ln, and then 1 over sine, so it's cosec. Cosec here multiplied, I get that. And then integrate both sides. Sine 2t change to 2 sine t cos t, so sine t cancel, we get cos. Integrate cos, we get sine. And that is it, I think. Yeah, that should be fine. So I'm going to go with it. So this is x equals, now we have solved for a. So 2a would be 300, right? Because a was 150 about. And then plus c would be that divided by cosec t. So sine divided by cosec, that would be sine squared. Yeah, I'm dividing across by cosec t. And divide by cosec, that would give me a sine t. So that's basically it. That's x in terms of t. I hope that's fine. Part C. Use the model to determine the time at which the Rambler will return to the bottom of the hill. This model right here. The bottom of the hill would be, because the Rambler starts a walk at the bottom of the hill. So the bottom of the hill at the start would be at t equals 0. So if t equals 0, if t equals 0, wait, hang on. Okay. If t equals 0, this side will be 0, this will be 0. So x is 0. Right, yeah, that makes sense because x is meters from the bottom. Alright, so we just put the whole equation to 0 basically. So 0 equals 300 sine squared t plus 0.687 sine t, yeah? And then we solve. So that would be, well, we already got one of them, the sine t equals 0 here. The other one is sine 300 sine t plus 0.687. So basically we need to solve sine t equals minus 0.687 divided by 300. I don't like the number here. It's too small somehow. Yeah, it's very small. Well, let's go with the flow, right? Well, this is sine of a negative, so I should get 2 quadrants down there. So let's do arc sine with the radian again. 0.683 divided by 300. That's pretty small. Okay. So what's that? T equals, this is the first one, so this one should be hang on. Yeah, okay. So it's pi plus, let's make alpha the principal angle, so that's basically arc sine 0.683 divided by 300. So that's just pi plus alpha and 2 pi minus alpha. Just we want the time at which will return to the hill to the bottom again. So it's just the first answer. It's just pi plus alpha there. So it's just, we just add this with, wait, this is 300. Okay, I almost flopped there. Okay, so we just add this with a pi. Yeah, so we get 3.143882 blah blah blah. So that's just 3.14, how many sig figs? Yeah, just 3, I guess, hours. Just gonna go with that. I guess I don't have time to double check here. I'm just gonna go with the method marks. Given that the vertical displacement of the top of the hill is that top of the hill, okay, use the model to find the value of t when the Rambler reaches the top of the hill. We just equate, right? Okay, so 300 and 0.68 equals 300 sine squared t plus 0.678 sine t. Okay, let's do quadratic, right? So sine t is, so we're just gonna do quadratic solver. So that's 300 for the first one. The second one is 0.683, and the third one is minus 300.68. Similar number there at least. Okay, so the first one is, ooh, that's horrible. Okay, minus 1.0. Wait, that's okay. That's over 1, right? This is no solution. Or sine t equals, the other one I hope should work. Yes, 0.999988. That's horrible, no? Okay, this is no solution. And okay, so we're gonna go to the normal mode and use this. So we do arc sine 0.999988. So that gives me t equals 1.56589 blah blah blah. So that's just 1.57 hours. Yeah, okay, I'm gonna go with that, guys. Using your answer to part C and D, give a limitation of the model. So the bottom is at 3 hours, but the top is 1.57 hours. So you're reaching the top before the bottom. Interesting, right? Hang on. This one is close to 1. Is a positive, so ooh, we could have this one and that one, right? walk from the bottom and you reach the bottom again, how do you reach the top way again? Hang on. Use the model to determine time at which Rambler will return to the bottom of the hill. So you go to the top first. The vertical displacement to the top is 300. Use your paths C and D, give a limitation of the model. I have no idea. Now I'm a bit in a rush. Okay, so hang on. Let's talk about the time there. So you go from the bottom to the top, and then the top to the bottom. Hang on. 1.5 hours. This is like double. Okay. I see. So time taken from bottom to top is about half of top to bottom. You see, guys? I mean, if I'm right here, it's not realistic because you would spend time going up more than time going down, because going up takes more energy. You have to defy gravity. Not realistic. It's about the same, I should write. Yeah. The same as, because you first reach like 1.57, and then this is like, you know, you can see that it's 315 equals about 2 times 1.57. Yeah. Not realistic as would take more time to go up than to go down. I don't have much time, so that would be my answer there. I have 10 minutes for 2 questions. Let's see if I can make it, guys. I doubt it. Right, but I'll walk through the last one if I don't finish it in time. So part I, curve with equation that, okay, intersect just one point P. Use algebra to show that. All right, so we need to equate the two, right? Okay, so 3/4 sinh x equals tanh x plus 1/5. I think we're gonna go with the hyperbolic definition. So this is just times 1/2 e to the x minus e to the minus x equals, what's that? Tanh would be e to the sine over cos, so x minus e to the minus x divided by e to the x plus e to the minus x plus 1/5. All right, okay. What should I do with this? If I multiply out by e to the x plus e to the minus x, I should get 3/8 there. Multiply this out, you get, wait, hang on, I should multiply that as well. Okay, so this is e to the 2x minus e to the minus 2x, just difference of squares there. And this is e to the x minus e to the minus x plus, because I also multiply that, so e to the x minus plus e to the minus x divided by 5. Okay. Okay, I'm a bit troubled here. Hang on, let me just... Oh, yeah. So if I multiply across by... Okay, I'm just going to do common difference, just 8 and 5, so we have 40. I'm going to multiply by 40, e to the 2x, yeah? Because I see that they have e to the 4x there. So this will be, multiply 8, we get 5, so 15 e to the 4x for the first term. And also minus 15 e, and that's it. Well, no e, equals, what about this one? Well, actually, this one we can do some work first. So if we, okay. So this is 1 and 1/5, right? So 1 and 1/5, that would be 6/5. 6/5 multiply 40 would be 8 times 6, so that's 48 e to the x. The other one, minus 5 plus 1, so it would be minus 4/5 for the other one. Minus 4/5 times 40 would be minus 32 e to the minus x, right? Should I get that? Yeah, I hope. Yeah, I did. Wait, hang on. And multiply by e to the 2x as well, I forgot. So this would be 3, this would be 2x, right? Yeah, okay. Yep, and then hang on. Oh, should be just 1, hang on. Yeah, this is just minus just 1 e to the x. Yeah, all right, I think I got it. So 4 minus 48 e to the, oh, 15, sorry. Yeah, the first term is right, so 15 e to the 4x minus 48 e to the 3x plus 32 e to the x minus 15 equals 0. Right. Part B, 6 minutes. Show that e to the x is 3, the solution. Because this is basically if we put y equals e to the x, right? This would be, so I have here maybe fy equals 15 e to the, wait, hang on, y to the 4 minus 48y to the 3 plus 32y, is it? Minus 15. And if we do f of 3, that would be 15, you know, I'm just going to write this. And I'm sure that this will go to 0. Yeah, because that's just the root using factor theorem. Yeah, so that's it. I think I'm going to go with that. Hence, state the exact coordinate of P. So basically, if e to the x is 3, then that means x is ln 3, right? Exact coordinate. So show that x coordinate is satisfied as equation. Exact coordinate, so x is ln 3. That means, okay, so y would be 3 over 4 sinh ln 3, right? Okay, 3 over 4 times 1 over 2 e to the ln 3 minus e to the minus ln 3. So that would be 3 over 8. ln 3 is, e to the ln 3 is 3. That would be minus 1 over 3. So that would be 3 over 8. So that would be 9 minus 1 over 3. So this is 3 cancel. So that would be 1. So coordinate of P would be ln 3 and 1. Just solve that. Part II. Show that. Okay, this is a different kind of question. And good that this is not improper integral. So how do we integrate that? Don't tell me this is by part or something. Let me think about that first. Interesting there. E to the minus x. Ooh. E to the minus x. So, okay, so you would have e to the minus x, right? Wait, hang on, that's not even minus x. That's 1 over x. And this is x of minus 2 dx. How do we do that? Okay. You can't integrate e to the 1 over x, but you can differentiate that. Okay, right. So by parts, really? So I'm going to put that as u, that as dv. So that's going to be uv. So u is e to 1 minus 1 over x. Differentiating that, we get minus 2 in front here. So, okay, v would be minus 2. Wait, no. It would be minus 1 over x. Minus, yeah, okay. So we have a minus here, and then x to the minus 1. Minus integral, out of time. Yeah, definitely, I'm not gonna make it. U du, so e to the 1 over x. Differentiating 1 over x, you would get minus 1 over x squared. Yeah, multiply minus 1 over x there, dx. Okay. That's not gonna make it somehow. Differentiating that, you get that. So it's probably not gonna work, I think. I have no idea. Okay. Let me skip this one. Let's see the next part. If I can get any marks out of that, yeah, that would be what I do there. Let's see. Okay, the Moivres. Yeah, we should have skipped to this one. Algebraic integration in part A determine. Yeah, right. Yeah, definitely. Part A we can do it. Yeah, so that would be if we put z equals cos theta plus I sine theta. So z plus 1 over z to the 4 would be z to the 4. Well, that would be 14641, right? So z to the 4, I'm just going to do 1 over z to the 4. That would be, this is all plus, right? Oh, it's a sign, so I need a minus. So I should do a minus here. This should be a minus, and then there would be minus 4 z to the 2 plus 1 over z to the 2. I just happen to remember that. This is plus 6. Okay, so this will be 2I sine theta to the power of 4 equals z to the 4 plus 1 over z to the 4, so that's 2 cos 4 theta minus 4. This is a plus as well, so that's cos 2 theta plus 6. So that would be 16 sine squared equals 2 cos 4 theta minus 4 cos blah blah blah. So if you divide across by 2, you should get cos 4 theta minus 4 cos 2 theta plus 3. This should be 8, sorry. Yeah, at least I got this. Okay, and my time is up. So I'm just going to mark the paper and correct the ones that I didn't do, or the ones that I got wrong. Alright, see you in a bit. Okay guys, I have marked the paper. Didn't do all that well. Spent too long correcting mistakes and probably talking too long for the first few questions. So let's go through the mistakes. Yes, some of them are very stupid, like this one, you know, like the first one here. I probably annotated the video already, but this should have been -2. That's why I got some weird answers there, and just take my marks away just by -1 there, because I think the answer to that part is just like the values of a are not that like, because we got the method here, so for the equation, so the final accuracy mark I lost, so that's -1 there. So the answer should have been, so if we correct that, right, that should be a squared minus a minus 2 equals 0, and that's just a minus 2 and a plus 1. I just didn't have any second thought for that. Just went for that route, which is, yeah, so a is 2 and minus 1. Yeah, so I lost a mark there. Everything else is fine, including the inverse, at least, thank God. And yeah, this one, also another stupid mistake. I used the arc, sine arc, cos formula here, and I put the wrong form here. This should be a minus. I used the wrong formula. And also the final accuracy mark, I got the mark for this one, so I lost 2 marks here. Now, the answers, right, there should be 2 answers. I mean, if you use the formula sheet, there's only 1 answer when you do arc cos. But if you solve the quadratic, yeah, so let's solve quadratic. So if we solve this equation here, that's going to be e to the x plus e to the minus x over 2 equals 3 over 2, right? So if we put the cos, the hyperbolic form, I mean the exponential form of the cos x equals the 3 over 2, we get this. And then if we solve this, right, so 2 cancel here. And then if I multiply out by e to the x, I get e to the 2x here. I would get 3e to the x here. If I move to this side, I get 3e to the x, and this one times e to the x will be just 1, right? So if we solve the quadratic root here, e to the x will be equal to, using the quadratic formula, you get minus b, which is 3, plus or minus square root b squared, which is 9, yeah, minus 4ac, which is 4. So that would be root 5, right? That would be root 5. I'm just saying, and over 2a, which is 2. I'm just saying, if there's no negative root for the e here, you can see 3 is greater than root 5. So although being subtracted by root 5, still going to give you a positive value here. So if both roots, quadratic roots, are positive, then you should get 2 answers here. That's why you would have, if you solve the x here, you get ln of that and ln of that. So 2 roots there. So I lost another mark there. Yeah, okay. Number 3 is all fine. Number 4, all fine. Number 5, all fine. Number 6, all fine. Yeah, I did a home run there, all of those. Number 7, although spent quite some minutes correcting everything, redo everything again, but still managed to get it. Good. Number 8. Yeah, number 8 is not wrong, but 0.8 687 here, well, could be ignored, right? It could be ignored. I mean, if you ignore this part, all the answers for this one and the other one, this one, will still be the same because it's too small. That's why I was, I was a little surprised, like the number is very close to 1 and to pi and everything. But this is nothing wrong here because we solved it, strictly speaking, to find C, but it's very small. So you can ignore it, but you still get the mark here. And this one is correct, this one is correct, and this reasoning is correct, right, for the model there. Because the time taken to go up is equal to that to go down, but it's not realistic. Number 9, yeah, okay, so yeah, need to do this one, the second one here. Okay, let's have a look at number 9, yeah, because it's the one I kind of like didn't manage to do. So basically what it is, let me just string everything here. Okay. So yeah, I got -4 there because I didn't try it. Okay, so I mean, you need to integrate this first and see what happens. Okay, so if we integrate it, but how do we integrate it? Yeah, I didn't think of substituting u as 1 over x, right? That might work, yeah, because then you would have integral of e to the u divided by, well, x to the 2 is basically 1 over u squared, right? So this is 1 over u squared. And then if we differentiate u, we get du by dx equals, well, that would be -1 over x squared, right? So dx is just minus x squared du, right? So this is minus x squared du, yeah. And minus x squared is basically 1 over u squared, right? There you go. -1 over u squared. Yeah, we can also do that. So instead of writing minus x squared, I'm going to write -1 over u squared du like that. Okay? And as you can see, there's some cancellation here because this guy can cancel that guy. Right? Yeah? Because x squared is 1 over u squared, so it's going to cancel with that. So we only have the integral of e to the u, and that's just minus e to the u here. Because e to the u integrated, you get e to the u. Okay, and minus, I put it out. Now, the bounds, right? Because, look, if, what do we have? If x is -4, u is -1 over 4. That's simple. But if x is 0, right? You can't really find u there. Okay? So what do we do here? So if x is 0, let's put this as x equals t. Yeah, so that's how you do improper integral. So this is improper integral. So if x equals t, we're gonna have u equals 1 over t. All right. So the upper limit. So let's do the lower limit first. So the lower limit is just -1 over 4 there for the u. Yeah. But the upper limit, well, it's just gonna be 1 over t maybe. But here we have limit of t approaching 0. Right? T approaching 0 there. Okay? So what are we going to have is that we're going to just substitute, wait, hang on, this is, yeah, that's right, okay. So we're going to have minus, right? Substitute everything in. So I have e to the 1 over t, yeah, and then minus e to the -1 over 4, like that. And this is the limit of, well, let me just swap the sign there, yeah. So I instead have, swapping the term, e to the -1 over 4 minus e to the 1 over t, like that. And the limit of t approaching 0, right? Yeah, it's improper because look at the way it is. So you can't really sub. I mean, if you find the bound or the upper limit for u here, it would be 1 over 0. So that's improper limit there. So that's why we need to take limit here. Now e to the -1 over 4 is fine, right? That's no problem there. But when you do t tend to infinity here, this will become like a very large number, right? So 1 over t when t tends to infinity, when t tends to 0 will tend to infinity. Now this is the important point. I forgot to mention that because the bound, the upper limit is the problematic one, is the improper one, but if you look at the lower limit, it's a negative. So it's from a -4 to a 0, so that is coming from the left. When you take the limit, this must be negative here, right? So it is saying that it's going to come from negative infinity to 0. Yeah? So that means you can convert that. So it's like when you want to find the actual thing, you substitute in here. So basically, if you take the limit of t tends to 0 from infinity like that, so it's from negative infinity to 0 of 1 over t here, this is going to be equal to minus infinity, right? Because you go from minus infinity, it's going to be a negative number basically. So that's why you get minus infinity there. Yeah. So when you substitute in here, actually, it's going to be e to the minus 1 over 4. And this will be e to the minus infinity instead. Because 1 over t, limit t from negative infinity to 0, will be negative infinity there. And this will vanish to 0, right? This will vanish to 0. So that's why we're going to get e to the minus 1 over 4 there as required from the question. All right. So that's where I went wrong. And yeah, improper integral. Didn't think about that. Yeah, and the last one here, I thought I got it, but I forgot to put 8 here, guys. So I just forgot to put 8 there. So there's a minus 1 here as well. Yeah. But okay, we can use that form now to do the next part, b, which is to find the integral. So it's just solid revolution. Yeah. So let's do it. Yeah. So we need to integrate pi x squared dy, right? That's what we need to do. And there's no scale factor here, so no worries about that. And let's just substitute x squared in. So x squared is just sine to the power of 4 y over 2 here, dy, right? And I'm just going to ignore the limits for the time being. Yeah. So we're going to use this form here. That means if I manipulate that a little bit, I get sine theta, sine to the 4 theta equals 1 over 8 cos 4 theta minus 1 over 2 cos 2 theta plus 3 over 8, right? And we can use that result. So, I mean, we could just make theta y over 2 already, because everything you do there, if you put y over 2 instead, so that's going to be fine. I mean, I'm just saying that if you do sine squared y over 2 here, you should get 1 over 8, and then you put theta as y over 2 instead. Yeah, that would be cos 2y, right? Minus 1 over 2 cos y and plus 3 over 8. Yeah. Okay. I think that's just it. So we're gonna do pi integral 1 over 8 cos 2y minus 1 over 2 cos y and then plus 3 over 8. Yeah, we're going to keep the same form here. We don't need to change to theta or anything. Just use that. So we integrate 1 by 1. So integrating cos 2y, we get sine 2y, but divide by 2. So that becomes 1 over 16. This is just sine y here. And this is just 3 over 8y. With the limits from 0 to 8 pi over 5, right? Yeah. Okay, so seems like if we sub the lower limit in, everything will disappear, so that's convenient. We're just going to sub one of them, which is 8 pi over 5. So let's just use a calculator, yeah? So what I'm going to get? So I'm just going to do 8 pi over 5 and then store that as an answer first, yeah? And then I'm going to sub pi in bracket like that So the first term, 1 over 16 times sine of radian, 2 times answer, that's sine 2y, minus 1/2 times sine answer, and then plus 3 over 8 times answer, close bracket. That's about 7.3. That should be right. Okay. And then part C, comment on the suitability of the model. Well, this one basically gives you the density and the mass, right? So we find the volume. That's a bit scientific, but we find the volume just by doing mass over density, right? So mass is 6 grams divided by density 0.85. Just get the volume. That's 6 divided by 0.85, so that's about 7.0588. Well, that's about as close to 7.3, right? So let's find the difference. So 7.3 minus that divided by the value we compare. So which should be the actual one? So the actual one is 7.0588. So I'm gonna keep that as answer first. Wait, hang on. Oh no. 6 divided by 0.85. Store that as an answer and then clear. So I'm gonna do fraction. 7.3 minus answer divided by answer. So that's about 3.4% difference. So suitable as the model predict volume that is within 5%. So it's up to how you say it. If you want to say it's good, then just say some reasonable tolerance, like 5%. So this is within 5% difference to the actual value. So suitable. That's how you comment. You gotta do some calculation, and that's it for everything. I didn't do so good on this. So let's do a review, an overview. I made a mistake on that one because I wasn't very careful about the A there and probably took too long to warm up. Okay, but everything is fine here, just no singular and non-singular definitions actually, and you got to be careful about A minus A less than 0 there, right? This one, you need to know that when you solve for arc cosh, arc sinh, actually it's safer to just solve quadratic manually because sometimes you can get 2 roots. All right, so I think you got to be careful for this one, and that's what I want to stress about this. So I lost marks here, right? And this one, fine, just go through the conditions and solve for all the possible values of z here. This is okay. Number 4, you need to go through the second ODE here if you don't know how to do this, but basically you need to learn a lot of cases. The case where on the right part, the non-homogeneous part, so basically if the right part is 0, we call it homogeneous second ODE. But if there's a non-zero function there of x, then you need to find the particular integral first. And there are cases you need to learn, like the linear case, the cos and sine case, the exponential case like this. Okay, you make sure you go through all of those. And the steps here, we need to find the complementary function first, and this is a repeated root. That's why I got a plus bx there, times e to the mx, which is 2 there, 2x, and then go through the steps here, so that's fine. This one, number 5, method of differences. Just make sure you understand how to go through the pattern cracking step there, just to find what is left uncancelled, right? So that's important. Number 6, well, this is not too bad, but you need to visualize this, so that like, it's just that the real roots are on the x-axis in the Arctan diagram, and the complex roots are anywhere. It can be anywhere, but we know the 2 complex roots here, so we plot them, and I made the vertical line the base. That's the key there, to find the area of the triangle. So use a bit of logic here, and then you should be fine, right? Okay, this one, This one was a real deal for me because I lost a lot of time just correcting my mistake. That was bad. I forgot to divide the thing by... That's a mistake I shouldn't have done. Yeah, I forgot to divide the whole thing by long division first. So I lost a lot of time there. So that was probably the thing that took so much time from me and I didn't make it at the end, right? But yeah, I hope everything is fine here. The part where you might... Maybe the only difficult part here is not the partial fractions, it's the integration here. So make sure you know how to split the term and integrate like that, right? And use the formula sheet to help you. Number 8, yeah, everything is okay, but you got to be careful with like when you substitute here. This is weird trig functions because it's sine 1 and cos 1 and everything. So all the numbers are weird here. It's weird to me at least. Yeah. They just want to do something weird to you sometimes, yeah, to confuse you. But again, as I said, this part here doesn't have to be, that. It could be 0, but it doesn't affect the answers to the next part because this term is negligible basically, but putting there might not, they might not penalize you, so I'm fine with that, I think. And yeah, the comment on the model is that, well, takes about the same time to go up and to go down, right? Which is not realistic in the real case. Yeah, this one, got to be careful with the part A there because you need to do some algebra work there. Yeah, so this might be tricky if you're not careful because the exponential terms might be confusing. Then the real deal here is the integration. So yeah, I need to put 1 over x as u because yeah, I mean, it's substitution with by parts together and improper integral. So this one 4 marks, not a lot, but not that easy to get either. Yeah, okay, but yeah, make sure you understand this part here. Why is negative infinity? Because look, if I had infinity here rather than negative infinity, it would go to infinity, and at least it's not the way the answer wants. Because the answer says you should get just e to the minus 1 over 4. That means if I got e to the infinity, that would have been divergent, would have been wrong. So that's why this limit needs to be from negative infinity to 0, right? That's why you get 1 over t as e to the minus infinity rather than e to the infinity, right? That's very important there. And the last one, yeah, the Moivres Theorem, yeah, I flopped a bit there, lost 1 mark. And yeah, you can use this formula any way you want. I mean, you can make this 4y, and this will be 4y, and this will be 4y. Just manipulate, just like when you use double angle formula, right? So manipulate the theta there in any way you want and use it to integrate conveniently. And then find the answer there for B. And for C, just comment. So basically, it gives you density and mass, you find volume, and you compare it to the predicted value from the previous part, which is 7.3 there. All right. And that was it, guys. So if you haven't checked other videos in further math, just go check in the playlist, and also other videos in other subjects like pure math. And stay subscribed because I'm going to create more and more video on these subjects and these papers. So I hope I'll see you in the next video. Bye.